Welcome to my channel Vijay's Physics Prints. Today we'll discuss about Wheatstone bridge. And this Wheatstone bridge we can construct by using of 4 resistors P, Q, R, S. These are the 4 resistors and these are connected in the shape of quadrilateral. A, B, C, D is the junctions. Okay, and IG is a galvanometer. And we can detect the current by using of this galvanometer in the given circuit, and we can connect the battery also, that is E, EMF electromotive force of the battery, it is E, and this is plug key K, right? So when you close this plug key, then current passing through the circuit, it is I, and this current at junction A, it is split into two currents, that is I1 flows from A to B, I2 it is flows from A to D, and at junction B, I1 split into two more currents, that is I3 it is flows from B to C, and IG it is flows through the galvanometer B to D, and at junction D, I3 IG combines and forms current of I4, it flows from D to C junction. And at junction C, I3 as well as I4 combines and forms current of I in the circuit. Okay, see, I am applying the Kirchhoff current law, Kirchhoff junction law at junction B. At junction B, what happens? At junction B. Okay, see what happens. It is at junction B, the current I1 split into I3 as well as IG. So I1 can be written as I1 equal to I3 plus IG, equation number 1. And at junction D, what happens? It is junction D, IG as well as I2 combines, I2 and IG combines, forms current of I4. Okay, and this is equation number 2. Now applying the Kirchhoff voltage law, Kirchhoff voltage law, second law, or it is loop law, right? So what happens at junction Kirchhoff voltage law for first loop A, B, D, A, B, D, A loop. Let me write the potential differences, then we can apply the sign conventions. So A to B, the potential difference, it is I1P, and B to D, that is IGG, and D to A, that is I2, are equal to 0. According to the Kirchhoff voltage law, the algebraic sum of potential differences in closed loop equals to 0. Now applying sign conventions, A to B in the direction of current, so it is minus, B to D same direction, minus, D to A flow of direction, we are moving opposite, so it is taken as plus, and the I1P, IGG bring out, then it can be written as I1P plus IGG equal to I2 R, equation number 3. Now we have one more loop, that is BCDB loop. So applying same Kirchhoff voltage law for BCDB loop. Okay, see how I can write this: B to C, C to D, and D to B. Let me write the potential differences, that is I3Q from B to C, C to D, I4S, D to B, IGG equal to 0. Now applying sign conventions, B to C in the direction of current, minus, C to D flow of direction, and we are moving opposite, plus, and D2B again opposite direction, so it is plus. I3Q bring out, then I3Q equal to I4S plus IgG, equation number 4. Here the very important condition it is the potential drop across junction B and across junction D. If it is same, VB is equals to VD. Potential at point B is same as potential at point D. Then no current passing through the galvanometer, nothing but Ig equal to 0. Then the Wheatstone bridge said to be balanced. This is a balanced condition. So balanced condition of the Wheatstone bridge it is Ig equal to 0. The current through galvanometer is 0. When it is 0 means when the potential at point B is same as at point D, then it's said to be balanced. Now applying this balanced condition in equation 1 and equation 2, equation 3 and equation 4. According to the first equation, Ig equal to 0. So I1 equal to I3. So for first equation is going to be modified like this. I1 equal to I3. And second is I2 plus Ig. Ig is 0. So I2 is equals to I4. The second equation is modified into I2 equal to I4. And third equation, it is modified, Ig value is 0, so the second term is totally becomes 0. Then becomes I1P equal to I2R. So this is the third equation, I1P equal to I2R. And the fourth equation, this is the value becomes 0. Then the fourth equation is modified into, this is I3Q equal to I4. Yes. Now divide those equations. This equation I1P equal to I2R and I3Q equal to I4S. Then it is modified like this. Right? So I am going to divide these two equations. I1P equal to I2R. Then I1 equal to I3, so I1, I3 cancelled out. I2 equal to I4, so I2 and I4 is cancelled out. Then the remaining equation becomes P by Q equal to R by S. So this is the balanced condition of the Wheatstone bridge. P by Q equal to R by S. This is the balanced condition of Wheatstone bridge. When it is balanced means when the current through galvanometer is 0, then the bridge is said to be balanced. Then in this case only, right, we are achieving the condition as P by Q equal to R by S. Okay. And see some more extra points in the Wheatstone bridge. Right, first point already we discussed, potential at point B is same as potential at point D. Then no current through galvanometer, which is equals to 0. And second, if the value of potential at point B is greater than potential at point D, right? Potential at point B is more than potential at point D, means high potential to low potential. When it is possible means the value of QR is greater than PS, then current flows from current through galvanometer, nothing but Ig, it is flows from B to D. Direction of current it is B to D. And third it is the value of potential means if VB is less than VD, mean more potential to point D compared to point B, then when it is possible means the QR value is less than PS. Now the current flows from D to B. Okay. Now one more point. We can construct this Wheatstone bridge by using of capacitors also. Instead of resistor, we can replace with capacitors C1, C2, C3 and C4. When you are constructing by using of these capacitors, then the balanced condition is going to be changed like this: C1 by C2 equal to C3 by C4, right? And one more point, what is the total resistance of the circuit? Total resistance of the circuit, Wheatstone bridge. PQ series combination or S series combination, and resultant it is in parallel, so the effective resistance of the Wheatstone bridge can be written as PQ on series, so P plus Q and R plus S by P plus Q plus R plus S. So this is the effective resistance of the Wheatstone bridge. And one more point it is, see in the diagram, battery and galvanometer, you can interchange these battery and galvanometer also, still balance conditions exist. So we can interchange the battery, or the cell and galvanometer also, right? At balanced condition, we'll get the same condition as P by Q equal to R by S. So no change in the balanced condition, right? And how the questions is going to be asked in entrance exam. See, this is one model question is given, and this is the Wheatstone bridge shown in the figure. Current through galvanometer will be 0, so it's said to be balanced condition, and we have to calculate the value of X. See this diagram, this total value, it is resistance P, and this total value resistance Q, and this is R, and this is S. So what is the value of P? P equal to 5 ohm are parallel combination. So the resultant is R1 R2 by R1 plus R2, that is 5 into 5 by 5 plus 5, which is 25 by 10, 2.5 ohms. This is the value of P. And Q, 2 ohm, 3 ohm are in series combination. So series combination resultant is R1 plus R2, that is 2 plus 3, which is equals to 5 ohm. And R value is given directly, no need to calculate again. And S, it is combination of X is unknown and 40 ohm in parallel combination. So R1 R2, 40X by 40 plus X. Now applying the Wheatstone bridge condition. What is the Wheatstone bridge condition? It is P by Q equal to R by S, right? P value, it is 2.5. Q it is 5, is equals to R, it is 10, and this is 40X by 40 plus X. Now solving for the X value, right? Solving for X. See, so 2.5, it becomes 1 by 2, which is equals to 10. 40 plus X by 40X, right? That is 2X equal to 40 plus X. Then solving for X bring this side, 2X minus X, that is equal to X. So the value of X, unknown resistance, becomes 40 ohms. So this is the value of X, unknown resistance, in the given question. So like the question will become in the entrance examinations. Okay. Thank you, and subscribe, support my channel. Thank you all. Have a nice day.